Hi everyone, this is Ms. S. from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 3-7, on the slopes of parallel and perpendicular lines. We don't have a lot of vocabulary to get through, but we do have a lot of work, so let's go ahead and get started. Alright, the equation for slope is always the letter m, and it's the change in the y values, or y sub 2 minus y sub 1, divided by the change in the x values, or x sub 2 minus x sub 1. And this is how this might look on a graph. You may have heard it's the rise over the run. So what you do is you actually count the boxes, 1, 2, 3, 4. So the rise of 4 over the run of 1, 2, 3, 4, 5 boxes. So the slope of this line is actually 4 over 5. Now, for parallel lines always have the exact same slope and different y-intercepts. So just like in this image down here, the slope of the top line is a positive 2, the slope of the bottom line is a positive 2, or exactly the same. But notice that the y-intercepts, one is at positive 3 and one's at positive 1. So the exact same slope, but different y-intercepts will always get you parallel lines. All right, from our practice part 1, you guys, this is question number 1, and it wants to know whether or not these lines are parallel. In order to figure that out, we have to determine the slope of each of these lines. So to determine the slope of the red line, we go up the rise, up 1, 2 spots, and we go, so 2, and we go over 1, 2, 3, 4, 5, 6 spots, which can be reduced to 1/3 in the red. And in the green, we do the same thing. We go up 1, 2, 3, 4, and we go over 1, 2, 3, 4, 5, 6, 7, 8 spots, which reduces to 1/2. And 1/3 and 1/2 are not exactly the same. Therefore, these are not parallel lines. All right. Now we're going to write an equation with parallel slope. This comes from practice part 1, and it's question number 6. So we're going to write this equation. So the first thing we have to do is figure out what the slope of the line that we have is. The easiest way to do this is to solve it for y using our algebra to put it into slope-intercept form. And so then we would divide everything by 2, and we would get y equals 1/2 x plus 2. So the slope of the line we currently have is 1/2. So we would need to look for options that start with a slope of 1/2. Now to put this into an equation, we could put it into an equation in point slope form. Remember, our slope always goes in the middle, it's the m, and then our point here, our -2, +4, is going to switch sides and signs. The 4 was in the back being positive, now it's in the front being negative. The 2 was in the front being negative, now it's in the back being positive. And you could further continue this on and put this back into slope-intercept form if you wanted to using algebra like this. And so you would just solve the equation for y. All right, now on to perpendicular slope. Perpendicular lines have negative reciprocal slope, which means whatever your slope is of the line that you have, you change the sign and flip it over. So if you have a slope of -3, in order to make it perpendicular slope, you would make it a +3 and flip it over to 1/3. So the perpendicular slope of a line would be -3 and +1/3. From our homework again, this is practice part 1, question number 8, and it wants to know if these are perpendicular or not. So we're going to do the rise here, down 1, 2, 3, 4, 5, 6, 7. So down 7 in the black, and over 1, 2, 3, 4, 5, 6, 7. And -7 over 7 is a slope of -1. And in the orange, we have to go up. We have to go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So rise 4 and over 5, which does not reduce to -1, but it also is not a negative reciprocal of -1, which would be +1. So these are not parallel. Sometimes they may ask you to write an equation with perpendicular slope. And so this comes from practice part 1, question number 10. So again, the first thing we have to do is figure out what the slope of the line that they've given us is. So to do that, we solve it for y and we get y equals negative 2x minus 8. So the slope of the line they've given us is negative 2. The perpendicular slope of that would be to flip it over and change the sign, making it positive 1 over 2 will be the slope that we need to use. So we would have y, little space, like this. Our slope, remember, always goes in the middle. It's the m. And then our point here switches sides and signs. So that would be one acceptable answer. And you could also solve this with algebra like this to get it into from point slope form into slope intercept form. All right, our last bit today. Sometimes they might ask you to write an equation from 2 points. This comes from practice part 2, question number 11. So if they've given you only 2 points, you have to find the slope between those 2 points first. So remember, you have always x's and then y's, and it doesn't matter which one you make 1's or 2's. So when we plug these into our equation, negative 8 take away a negative 2 over negative 5 take away 3. Remember, negative and negatives are actually positives. So we have negative 6 over negative 8, which reduces to positive 3/4. So that's the slope of the 2 points that we've been given. And we can use either of those 2 points. It doesn't matter which one you choose. We can put our slope here in the middle. And let's say we wanted to use 3 common negative 2. The negative 2 would move to the front, become positive 2. The 3 would move to the back and become a negative 3. And that is a perfectly acceptable answer. If you wanted to use the other term, you could do that as well. You would simply get rid of these here. And if we wanted to use the negative 5, negative 8, it'd become a positive 8 in the front and a positive 5 in the back. Good luck, everybody. I hope you guys do great.